Okay, so simplifying algebraic expressions today. When we're doing that, there's actually a couple of different things that can help us simplify, and one of those things is called distributive property. Does anybody have any, idea of maybe what operation happens in distributive property? It's multiplication. Okay, oops, I guess I need a pen. Is multiplication over addition or subtraction? Because sometimes, here's what happens. Whatever's inside the parentheses, there might be an addition or a subtraction problem inside some parentheses. And I think you guys are familiar with that. Order of operation says you're going to do parentheses first. And then you move on to exponents. And then you move on to multiplying and dividing, and then adding and subtracting. But in this, sometimes what's inside the parentheses really can't be put together. You can't really add them together. An example of something like that would be x plus 4. Can x be added to 4 without you knowing what x is? What do you think? No, I can't. So then, if we can't do that, then we have to find another way to get rid of those parentheses. And one of those ways is by doing multiplication. And it's called doing distributive property when we do that. So we're just going to practice that today so that when we have this happening in our equations next week, we know how to handle that. So this says that we're supposed to take 3 times the sum of a number and 4. So we can't really add that number to 4 because we don't know what it is right now. So we're going to do what's called multiplication over this addition problem. So we're going to multiply by this 3 each of the pieces that are inside those parentheses. So I want you to show those steps. 3 times the n plus the 3 has to also get multiplied times the 4. And the addition sign came from right here that we have right here. Okay? So if we have addition there, we bring that down in between our 2 multiplication problems that we have going on. Have you ever seen distributive property or done it before in other math classes? Yes? Okay. And did you have a certain method that worked for you? Or am I doing it differently than you did it? Who knows, huh? Okay, well, then let's just carry on. What's 3 times n? Anybody know?
3n.
3n. Bring our addition sign down again. What's 3 times 4?
12.
12.
No, we don't want the 3, huh?
But, wait a minute, do we have an equation to solve right now? No, we don't have an equation to solve, so we are just going to say to ourselves, can I do anything else really? No, because 3n and 12, can they be added together?
No.
No.
Because you don't know what n is.
We don't know what n is, right. So in reality, we have simplified our expression. So let's just put here, this is called a simplified expression. There isn't going to be any solving involved today. We're just going to practice simplifying. Okay, why don't you try the next one on your own and showing the steps of work. Do number 2 on your own, showing the steps of work that we just did. At some point, I'm going to let you, maybe not show me as much work, but until I know you really know how to simplify properly, I have to see that part, okay? Okay, anybody want to share what they believe the simplified expression should actually be? Dakota?
Negative 8x plus negative 8.
Negative 8x plus negative 8. How many of you agree with Dakota that that's the simplified expression? Okay. So we take the negative 4 times both pieces. This multiplication becomes the negative 8x that Dakota's talking about. This multiplication becomes the negative 8. Okay. But we're also going to learn how to clean things up. This is not how we would see that answer in an answer bank. In an answer bank, do you know what I mean? Like we've had those worksheets where there's a bank of answers, or you're on a multiple choice test or something.
Like the thing we just did.
Yeah, like the thing we just did, an answer bank off to the side. Well, this is not how they would show that answer in an answer bank. So we're going to put what I call the cleaned up answer, okay? We're going to clean this up. Negative 8x is still negative 8x. That's what it is. But it's kind of like we're going to undo somebody having changed it to add the opposite. We're going to make it back into a subtraction problem. We can make this addition sign become a subtraction problem.
And then the 8.
And the opposite of negative 8 is
Positive 8.
positive 8. Yeah. So this is how we would see it in an answer bank. This is what we call the cleaned up answer. So anybody think they can see just like a really quick shortcut here that your brain can tell you you're going to do when you see double signs like that? If you have a plus and minus, what do you think you're going to be able to do?
Switch the signs around.
Not switch the signs around necessarily, because we don't have those signs here in our answer anymore. So what really happened to this negative sign? It became
Positive.
subtraction, didn't it? And we just kind of pushed the plus sign out of there. It's not there anymore. Okay, how about number 3 here? Oh, we have just a minus sign, a negative sign in front of our parentheses, 5 minus y. Okay, we're gonna do two things actually before we actually do the multiplication. We're gonna show that we can really take that negative sign and make that a negative 1. Okay, so I want you to do that. Make that negative sign a negative 1. Because we can multiply anything by 1 and not change its value. So it's kind of like we're slipping in a 1 in there and saying, okay, well, let's multiply by 1. And then we're going to change the subtraction that is inside the parentheses to add the opposite, and that will become a negative y, and we're also going to slip a 1 in there. So when there's not a number there that's being multiplied by, we can slip a 1 in there. So we're kind of getting it ready to simplify. And these are the ones that trip students up the most. So I think if you will be willing to get on board right away and do this extra step, you're going to find yourself being more successful. Now we'll do our multiplication. We have a negative 1 that's going to be multiplied by the 5, plus we need a negative 1 multiplied by the negative 1y. So we're doing the 2 multiplications here. Okay, what is negative 1 times 5? What is
Negative
that?
5.
That's negative 5. What's a negative 1 times a negative 1?
1.
A positive 1, isn't it? And then it's still a y. So the negative 1 times the negative 1 becomes a positive 1, and then we still have it times y, so we have to have a 1y. Okay, now, I'm going to tell you right now, that's probably not how we would see that answer in an answer bank either. Typically, the variable part is to come before the parts that don't have variables. So we're gonna let this, in addition, can things trade places? Yeah. So we're going to let the 1y and the negative 5, first of all, trade places. And then we're going to clean that up. What can be cleaned up out of there? There's 2 things I'm going to tell you right now we can clean up out of there. What do you think one of them is? Dakota?
Change the addition sign to subtraction.
Okay, we can change the addition sign to subtraction, so it's going to become minus 5. Is that what you're saying? Okay. What's the other thing we can clean up out of there? Anybody have any idea? What do you think the other thing is we might be able to clean up out of there? What do we sometimes insert that we can also take out of there because we really don't need it? Dakota?
The negative sign.
No, the negative sign became our subtraction sign. We've already taken care of this part right here. We've already cleaned that up. That's right here. What else can we do, Cameron? The 1 can be ditched and just make it y. Because 1y is the same as y. 1 times y is still just y. Didn't we learn that? Didn't we say that? Whenever you multiply by 1, it doesn't change it. So this is really how we would see the answer in an answer bank. Okay? Y minus 5. And it's going to be important that you understand how to clean them up because they don't typically leave them not cleaned up. Okay. Using this, some of the same stuff we've just done, changing subtraction to add the opposite, inserting a 1 where we need to. Why don't you try number 4 on your own here? Just do the setup for me, that's all. Don't do the multiplying yet. Do what you think you can do to get it ready to multiply. It's just one thing, that's it. And when you think you have it ready to multiply, look up and see if you agree with me. Where we have a variable with a number in front of it, we can insert a 1. Where we have subtraction, we're going to change it to add the opposite. Anybody got questions about that before we go on and multiply? Okay, go ahead now and multiply. And then if in the end the answer needs cleaning up, see if you can get your answer cleaned up also. Okay, I come up with, before I clean it up, after I do my multiplication, I end up with negative 3x plus negative 3. Anybody want to agree with me on that step? No? Oh, then that's what it should be. What did I do wrong? Do you want to agree with me on my red step here?
I agree.
Will you? Okay, thanks. I got one supporter. Okay, 2, 3, 4. It's growing. Okay. Okay. Thank you. Okay, now, would we leave our answer like that? Would we see the answer like that in an answer bank?
Nope.
Okay, what would it look like cleaned up? What do you think, Cameron?
3x minus 3.
Okay, this will not change to its opposite. That's going to have to stay negative 3x, okay? That has to stay. It can't be changed. This is not showing subtraction here. This is a negative sign, so we don't want to get rid of that, okay? So we want to leave that as a negative 3x. And then what do you want me to do, Cameron?
Minus 3.
Subtract 3. You got blue, I guess. That's how we would see that one in an answer bank. So the first term cannot change to its opposite. No, we don't change that one. Nothing gives us any indication that we should do that. It starts out as negative 3x. It's going to stay negative 3x. But to get rid of the double signing, adding a negative, we can change that to subtracting the positive. Okay? Okay, then let's go to the back side where we're going to be doing some other type of simplifying also. Okay, hopefully you've heard of this before, combining like terms. Combining like terms, what does it mean, like terms? Does anybody know what like terms means? Terms that are the same. Well, we're going to put constants because constants are the same. 2 can be added to 4. Negative 1 can be added to 10. Those are constants. 2/3 can be added to 4/5. Those are constants. They have no variables involved in them. So those are considered like terms. And then terms that have the same variable part are considered like terms. So x's are like terms with other x's. A's are like terms with other a's. 3a plus 2a, those are like terms. So The other way to also simplify problems is that can you put some things together? Can you combine some like terms? So we're going to practice here 4x minus 1 plus x. Very first thing we're always going to do is change subtraction to add the opposite. So this is going to become 4x. Here's our subtraction sign right here. That's where we're going to make the change.
So plus negative 1?
Plus a negative 1. And what can we put in front of that other x?
1.
A 1. Okay. Now we look for what we call like terms. Constants are like terms. Terms that have the same variable part are. And then we'll just rearrange this. Well, I see some x's that are like terms, so I'm going to put them at the beginning of the expression. And then that plus negative 1. And it doesn't have, we had 3 terms, we still have 3 terms. All we did was rearrange, okay? We just rearranged them. Now we say, oh, these guys are both x's. So altogether I have how many x's? 5. That negative 1 doesn't have another constant to be combined with, does it? No. But do you think we're going to find our answer in the answer bank like this? No, it can be cleaned up. What can it be changed, cleaned up to be? 5x minus 1. That's right. There's how we would find the answer in an answer bank. Okay. Anybody got questions about that one? Is it?
I see 6.
You see 6. You want, or on number 6, you want to ask a question?
No, for number 5, I see 6 x's.
You see 6 x's. Where's the 6th x at? Let's see. We have 4 of them right here, and we have 1 more right here. Where's the other one? Does this have an x with it? Does this one have an x with it? No. Can't put one there. We don't have invisible x's like we have invisible ones. So we don't want to make that into an x term. That's a constant, we call it. Okay? Emerson.
Why do we keep changing to a subtraction instead of just keeping it addition?
Why do we clean it up like this? Because in algebra, they like everything with the least amount of anything written in the expression as possible. So like when we see x, they don't have the 1 there, do they? They clean that up and take it out of there. When there's plus a negative, they don't, that's like there's extra signage there we don't need, so that they change it to subtract the positive, because we don't show positive signs, do we? So in algebra, they just want everything as cleaned up as possible, is kind of the way. So we're just practicing that so in answer banks we'll see that. Now, I would not really count this wrong, I would not really count that wrong on a quiz, because unless I told you, you had to clean it up, okay? So, let's try this one. What's our first move going to be before we even try to combine like terms? Add the opposites. So we have 2 plus negative 4y. What's next? Plus
Negative 3.
Negative 3.
Minus.
No.
Plus.
Plus, we don't need to mess with addition. Addition can stay addition, right? Don't mess with it. We just want everything across the board to be addition. So all we really did is take these 2 subtraction signs and make them addition. Okay, now we're going to rearrange and group things together that are alike. And by the way, in algebra, letter terms get to be before constants. So we're going to let the y's come out front. It's just another thing that somebody decided this is the etiquette for algebra. Y's get to be first, and the constants are going to be second. So this is a positive 2 here, so it's a positive 2 here. This is a positive 2 right here, so it stays a positive 2 right here. And this is a negative 3 here, so it's a negative 3 there. So our like terms are the y's and the constants. So how many y's do we have? when we combine these two terms of y's? Negative 4y plus 2y. Negative 2y. Negative 4 plus 2 is negative 2. And then 2 plus negative 3. What's that?
6.
2, it's 2 above 0.
-1.
The temperature drops 3. It's at negative 1, so plus a negative 1.
That's not how we respond that in the answer.
That isn't how we would see it in an answer bank, is it? How would this look cleaned up then?
Negative 2y minus
Negative 2y minus 1. Yeah, that's how we would see it.
So is that homework about this?
What you're doing in your homework. So let's make sure we know how to do this, okay? So we've done two different types of simplifying here. We used distributive property on the front side, where we did multiplication over addition or subtraction. On this side, so far, we've done, do we have any like terms that can be combined? And that's what we were doing. Now, we're going to practice one problem where what if you have to do both things? Okay, what if you have to do both? Because I see some parentheses in here that look like the stuff on the front, and then I see something else tagging along with it. So let's first change it to add the opposite. So 5, 2x plus a negative 3. So that subtraction got changed. Now we're going to change this subtraction. Instead of minus 10, it's going to be plus negative plus negative 10. Now, don't start looking to combine any like terms yet. You always have to do distributive property before you do like terms, okay? Distributive property comes first. That's why it was on the front side. So we're going to do the distributive property here. This 5 has to get multiplied by just the things inside the parentheses. Only over that part that it is next to in the parentheses. So we have our two multiplication problems here that came from this. This is what they came from. Now this is what I call a tag along. It doesn't get multiplied by anything. Mia, what's up? Okay, 5 times 2x is?
10x.
10x. Plus, 5 times negative 3 is? Negative 15. Plus the tag along. Yeah. Here we've done our distributive property. Now we're ready to look to see if we have any like terms. Are there any likenesses here? The what? The constants. Okay, so we have these guys right here are like terms. And is it in the order algebra likes it? The x's are first, so we'll let them stay first. And then what's negative 15 plus negative 10?
Negative 25.
Negative 25.
That's not how we find it in the answer.
But that's not how we would find it in the answer bank. What would it look like in the answer bank?
10x minus 25.
10x minus 25. There we go. This is going to be a really important skill we can do to be successful next week with solving our equations. So do you have any questions right now?